Dear friends, in last sessions we were given some basic concepts of microprocessors, microcontrollers, the types of architecture, etc. Now this video is about basic aspects of microcontrollers, its architecture and the buses. As all of us know, microcontroller is a device that captures the input, processes it and generates output based on the information that is captured. We can say microcontroller is a on-board computer. Unlike microprocessors where we need external peripherals to process it, microcontrollers do not require any such peripherals because all peripherals required to process an information or an application is inbuilt in a microcontroller. Microcontroller has its own memory, microcontroller has its own peripherals like timers and other such peripherals required to process an application. So we can say microcontrollers are special purpose computers. So the block diagram of a basic microcontroller is shown here. It has an ALU, it has some general purpose registers, it has a RAM, it has a program memory, program counter and other registers associated with an architecture. Now we'll discuss about the classification of microcontrollers. Microcontrollers are classified based on various categories. One, based on the memory. Some microcontrollers have external memory, and whereas some microcontrollers are memory embedded into the chip itself. Those microcontrollers do not have memory on chip is called external memory microcontrollers, example Intel's 8031. And those microcontrollers with inbuilt memory are called embedded memory controllers, example Intel's 8051. The second classification is based on the type of architecture. Accordingly, we have two types of architecture that we have seen in the last sessions. One is von Neumann architecture and second is Harvard architecture. Von Neumann architecture contains memory that is common for both data and program, whereas Harvard architecture has separate memory for both program and data. The third classification is based on data length or ALU capacity, and accordingly we have classification like 8-bit, 16-bit and 32-bit architecture. For 8-bit microcontrollers, the size of ALU is 8 bits in length, which can process data on 8 bits at a time. Example Intel's 8031 and 8051, etc. 16-bit microcontrollers is an application where high accuracy and performance is required. It can process data on 16 bits of data at a time. Intel's 8096 an example for 16-bit microcontroller. 32-bit microcontrollers are used for more or for wider applications and has superior processing speed and can handle multiple peripherals and used in automatic control appliances like medical appliances, computer applications, etc. The fourth application is based on the instruction set. This also we have seen in the previous sessions. One is CISC architecture and other is RISC architecture. CISC stands for complex instruction set computing and RISC stands for reduced instruction set computing. Both has its own features. CISC has much versatility with respect to program writing because you have large number of programs and according to your choice, your algorithms, you can write programs. Whereas with RISC, it's a register oriented architecture where number of instructions are limited but they are faster to execute because a register type architecture. Another parameter that we need to know about microcontrollers is regarding address bus, data bus and control bus. So these buses are available both in microprocessors and microcontrollers. Address bus, as you know, processor sends information to the memory location via address bus. Each memory location is identified by an address. Like identifying a house, we need an address. Similarly, for identifying each memory location, we need an address. For example, you consider a 1 kilobyte of memory. 1 kilo means 2 raised to 10. So there are each location can be identified by 10-bit binary. So suppose 10 zeros are there, that is the first location. 0, 0, 0, 0, 0, etc. up to last one, it going to be the first location. 0th location, first location. 0, 0, 0, 0, 0, 0, 0, 1, 0 is going to be the second location and so on. So each location will be identified by address. And to communicate a processor with the memory, the information will be sent through address bus, and to remember address bus is unidirectional, means from processor information is sent to the memory and the reverse transmission of data is not possible in an address bus. Second is data bus for transferring data from processor to memory or vice versa or to peripheral. So that's going to be a bidirectional bus. So it is possible that processor can send data to memory or peripherals. Similarly, peripherals or memory can send back data to the processor, and that takes place through data bus. And control bus, that is going to the synchronize operations between memory, CPU and other peripherals, so that the information is such information are passed through control bus. So these are the important buses. Bus is nothing but a group of conducting lines or wires. Now let us discuss about registers. All processors has its own registers. Do remember, the architecture of register is identical to the architecture of processor. Therefore, registers are much faster in operation and simultaneously it's going to be very costly. Therefore, in all processors, size of registers is limited. Registers are temporary storage that is used to process operation on a temporary basis. Register can hold an instruction, can hold an address, or can hold any type of data. There are two types of registers in any architecture. One is general purpose and other is special purpose registers. General purpose registers can be used for any general purpose applications, means the application is not specified, whereas with the special purpose registers, the application or the task is particularly defined. Example for a special purpose register, program counter that holds the address of the next instruction to be executed, and content of program counter gets automatically incremented after each memory access so as to point to the next location in memory. Another example for special purpose register is stack pointer, pointing to the top of stack, and as we know, the stack is a set of memory locations specially used by the processor for storing information or for storing information for certain applications. And instruction register, that's also coming under the category of special purpose registers. Instruction register holds instruction that is currently being executed. Status register, status of operation. If the result of an operation is 0, 0 flag will be set. If the status of operation results in a negative or a positive sign, the corresponding sign flag will be set and so on. So this information will be stored into status register. Another special purpose register is accumulator. Most of the processors accumulator that holds one of the operand during arithmetic and logical operations. It also holds the result after arithmetic and logical operations. Then memory address register holds memory address of data and instructions. It accesses data and instruction from memory during execution phase of an instruction. So that's all about registers. So this session is over. Here we have given a basic architecture of microcontroller. Then we have seen different types of microcontrollers. Then we have seen address bus, data bus and control bus in a microcontroller. And also we have seen registers and its classifications like special purpose and general purpose registers. With this, let me conclude this video. Thank you. So in next video, we will be having more discussion on microcontroller aspects.